I feel incredibly honored to welcome Dr. Surendra Kumar Bhattacharya ji, an eminent authority in the field of petrified wood research. Sir's scholarly journey is distinguished by a wealth of experience garnered from esteemed institutes such as the Tata Institute of Fundamental Research, University of California, San Diego, and the Tokyo Metropolitan University. His research endeavors, ranging from triple isotope systematic of oxygen in chemical sediments to the study of ancient ocean conditions, have garnered international acclaim. As a fellow of both the Indian Academy of Sciences and the National Academy of Sciences, his dedication to advancing knowledge serves as an inspiration to scholars worldwide. Moreover, Professor's scholarly impact extends beyond academia, as evidenced by his extensive collaborations with scientists from various institutes. His collaborative efforts with colleagues from institutes such as IISc, IISER, IIT Kharagpur, IIT Madras, and Academia Sinica have led to groundbreaking research on isotope geochemistry and fossil woods. Presently, Sir's engagement with scholarly pursuits continues unabated, as he remains actively involved in research on petrified wood and related topics. As an international visiting professor at IIT Kharagpur and a visiting research fellow at Academia Sinica, Taiwan, Sir continues to contribute to the advancement of knowledge in his field. We are so very pleased to have you with us here today.
Good morning, everybody, ladies and gentlemen, and my respected teachers of the Priya School, my good friend, Dr. Nautiyal. I'm extremely happy to be here to give some preliminary impressions about the research that I do and isotope geochemistry field. It is a bit first time for me that I have never spoken to school children, so maybe I will be sometimes off the track. So please excuse me for that. But I really enjoy talking to young people because I feel that someday you will be the leading corners of this our country in the field of science and technology. So I will first tell you that what is it that we are going to talk about. We are going to talk about the fossil wood. I have brought a sample of fossil wood to be passed around. I am going to talk about the dinosaur excreta. The dinosaurs were in this world long time ago, and they used to eat food, and of course they will pass the poo, and that poo has been solidified and has been made into stone, and that stone is available to the scientist just like petrified wood is available. So I have got two samples of dinosaur like animal excreta, and they have been solidified. So again I want to pass this around to show you, and then I also have some samples of tooth of whale. In Jurassic Park you have seen that whale jumping around. That same type of whale, the tooth is here, and there is another one is a very ancient sea animal. It used to deposit calcium carbonate. So there are altogether 4 types of samples, and as we pass it around, please return me back because they have to be returned back to the VSIP. So see them and just pass around. When I say what is fossil wood, you can see an example of a fossil wood. This particular white part, the central part is called opal, and this sample is from Arizona. So these trees were alive and they were part of a big forest once upon a time. Then they fell down, they died, and in majority of the cases they will be decay. They will not survive because there will be various kinds of animals eat them. There will be oxygen which will oxidize them, so we will not get the samples of this easily. But there are fortunate circumstances in which they are buried and they are divorced from any animals eating them or any oxygen decaying them. So they survive, and eventually the organic matter of the trees get replaced by the silica deposit, SiO2, and these are the opal is nothing but SiO2, and sometimes they are so beautiful that they can be used as furniture in houses. The forests of these things are available in in many suitable circumstances. This is an example from USA, and this is an example from our country, not very far from here. It is, if you go down south from Lucknow by about 1,000 kilometers, you will go to a place called Ghuguha Fossil Wood National Park. And there are hundreds of such fossil wood you will find there. And these particular ones were eucalyptus trees, and they fossilified and became part of this Ghuguha Fossil Park. It is not always available, so in a particular place sometimes these forests survive. And in one of my trips to Japan, I have seen a forest being covered under seawater, because the sea might encroach the land and the whole forest got covered. So you can, if you have the capability, then you can walk into this forest, which is ancient time forest, probably 18 or 20,000 years ago. And those forests can sometimes become converted to the petrified wood. Okay, this is, I don't know how many of you have gone to Kolkata. There is an Indian museum there, National Museum, and there are petrified wood fossils there. That is the one where I am touching, and then there is a vertical one, and there are sometimes about 5 or 6 meter long, these fossil woods are there. So now these fossil woods tell us about the ancient times. Now how they tell us, I will give you in a very brief way. In ancient times, India was not part of the Asian continent. It was far away. It was in the southern hemisphere. And then it migrated, it got divorced from Australia and Africa, and it migrated towards the north and then hit the Asian continent, and that's how the Himalayas came up. So this long story, part of it was when India was in the equatorial belt. And at that time, around 65 million years ago, it was about 15-16 degree equatorial zone. And what you see is that rainfall and the climate was very different that time, because the dinosaurs used to roam. And dinosaurs, they need a lot of food. So how can they get the food until there is a big amount of supply? And this supply was the forest and all this, subsequent the food chain. So therefore, these dinosaurs sometimes could go into tremendously big sizes because the food was abundant, and evolutionarily there was no pressure. So they could grow very, very large amount of mass, and therefore the climate, the rainfall and other things, they are very, very different. Otherwise, how can the forest survive, right? So we study these petrified wood at that time. There are many times, but at that time, if we get petrified wood, then we can study their isotopes. Now I will just tell briefly about isotopes. I am sure many of you know about isotopes, but if we study the isotopes, and using the isotopes, we can tell what was the climate, what was the environment at that time. Okay, so it is such an interesting thing that we have indirect evidence from evolutionary tree of the dinosaur ended that there was a very convivial atmosphere, convivial rainfall, and temperature was very suitable. That's why these animals could survive. But we can get a quantitative estimate by using isotopes by the physical instruments. Okay, we study isotopes of the atoms to understand the rainfall and temperature and various environmental factors at that time. Okay, this is a very, very brief introduction to isotopes. I will not go into detail. We have hydrogen isotope of so-called hydrogen atom, hydrogen element, which has one proton and neutron is 0. There is no neutron. And there is something called deuterium, which has one proton and one neutron. And there is something called tritium, which has one proton and 2 neutrons. So these 3 kinds of hydrogen exist. That is a fantastic discovery for which one scientist got Nobel Prize. And these 3 isotopes of hydrogen exist in nature. Now you will say, where do we find them? For example, I was drinking a glass of water. Water is nothing but H2O. So there is hydrogen in that. And in that H2O, this H, you have both hydrogen, deuterium and tritium. All the 3 are present, except the deuterium and tritium are very much small in abundance. So you cannot usually detect by any other weight or big crude method. So you need very sophisticated machines to know their abundance, to know their amount. Another isotope is called oxygen, which is very popular, at least to me, because I do research on these 3 isotopes. So there are 3 isotopes of oxygen, 16, 17, and 18. Again, you will say, where do you find them? H2O molecules or atmospheric gas, O2. So these have both, all the 3, 16, 17, and 18. Now you see the 16 is the majority, 99.7, 99.8%. 17 and 18 is very small. But nevertheless, the information lies in that small one. Because, as my teacher used to say, an effect need not be large in order to be significant. An effect can be very small, but it could be significant. I will give you a very simple example. Supposing there is a murder in a house, and there is a drop of blood, extremely small sample. So in that drop of blood, do you know what we can detect to determine the murderer? We can detect the DNA of the, and therefore this is a very small effect, right? Very small item, but we can get the information. So here also 17 and 18 are very small in abundance, but we can measure them and get this information of this rainfall and temperature, because the abundance changes with this rainfall and temperature. That's why they're function of those. And this is due to the isotope effect. The isotope effect means oxygen 16, 17, and 18 do not have exactly the same property. Even though long time ago they were thought to be same property, that is why it is called isotope, that means same property. But actually they are not same property, they are slightly different property. And these properties can be used to determine the environment, the temperature, or what was the rainfall, or what was the pressure, etc., relative humidity, all these parameters. I will just briefly tell you how this wood became finally a petrified wood. It is because of the action of acid. There is an acid called silicic acid. The silicic acid is nothing but silica dissolved. Have you heard of silicic acid before any time? Okay, good. So if the silica dissolves in water, now you will say, where do you get silica? Silica is usually available from volcanic ash. So in those times there was a Deccan basalt and there was a lot of volcanic ash. And this volcanic ash may get dissolved in water and form silicic acid. That silicic acid may react with the wood, with the cellulose, hemicellulose, etc. of this wood organic matter, and convert it into the so-called opal, like silica. So there are, first silica is formed, and then this silicic acid is formed. Silicic acid reacts with the wood, and then again the precipitation of silica. So by this method, the wood gets converted to the opal and petrified thing. So for wood to petrify, as I told you, that it has to be covered, it has to be divorced, it has to be segregated from oxygen, and all the animals which eat the wood or the organic matter, all the bacteria and various kinds of other animals. And if this condition is valid, then we can finally get the petrification of the wood. And this, fortunately, when sometimes it comes up, it is exposed in Gugua National Park or Arizona National Park. So it is a coincidences of geological factors which brings the information of that time, the recorder of that time to you. So the nature is helping you to understand what was the situation like before. So information about the environment we can get from the isotopes, because as I told you, the isotope abundance depends on these various kinds of factors, and these factors can be then read from the abundance ratio changes, because changes of abundance ratio is a function of that. So how do we measure the isotopes? Naturally, it is a very difficult task, but there are machines available now which can measure the isotopes called mass spectrometer. Okay, so before going to that, there is another of the sample which is so-called dinosaur coprolite. It is nothing but dinosaur poo. So dinosaurs of various sizes, from small size to very big size. So there are various kinds of poos available. I also have got samples of, I think, crocodile poo. So this also I will pass on to among you. So these have been solidified exactly by the same action as we are talking about, where wood was solidified, but here the poo has been solidified. Now you will say that How do you get the information about the environment? Because what we eat, we become like that. So when the dinosaur or the animals ate those things, they were taking the information from the environment, the water and their internal temperature. Here I have the one crocodile thing, the poo. How do you know it is poo? Here there are, when it goes along the track, there are lines, and these lines have been petrified. So if you see under microscope, you will see those lines, the stomach lines, and that's how you can see that they are really poo. I mean that time. And this particular one is from a dinosaur. So we can use the carbon isotope of this to know what kind of food it was eating. Then we can tell what kind of trees were surviving. This is a machine which I used in the Academia Sinica, which is called a mass spectrometer. It is always under repair, always, because very sophisticated machine, so it is usually kept open, so it is not covered. So, but this is very, very precise machine. It can measure the abundance of all those small abundances, oxygen 17 and 18 and various other isotopes very precisely. And this is very essential to have such machine to measure. Typical cost is about 5 to 6 crore. So it is a little bit expensive, but we have to buy that in order to know this. This is little bit of chemistry or physics of the isotopes. We need this mass spectrometer has a magnet and an electric field in which the particles are accelerated and they bend in the electromagnetic field. You will probably learn about it either in higher level classes or in later on in BSc, that in electromagnetic field they bend, and they bend depending on their mass. And therefore, we can separate the masses and measure their abundances. Okay, this is another example I want to bring you where the environmental thing is recorded. This looks like a lake, but this is in the central, in the Madhya Pradesh, I think in Maharashtra. Here it was made by a impact of a stony meteorite. A meteorite fell from the sky, and it was such high energy and such high mass that it made a huge hole. About the diameter is about 3 or 4 kilometers, and this area is full of lot of rainfall. So finally, it became, and we believe that the meteorite is hiding below, or it has become completely powder. So there may be remnants in the thing, and there are some research going on in order to find those small fragments of the stone which has survived. So this is so-called lunar lake, but it was made by a meteorite. Again, it is from the extraterrestrial impact of a stony thing. This is a very famous meteorite crater in USA called Arizona crater, and I was fortunate enough to go. You can see the central part, there is a white building. Can you see a small white thing? That is a building, because the person who owns this place, he thought that meteorite was a iron meteorite. So okay, this iron, it has fallen and it has gone there. So if I dig it, I will get the iron, and then it is free, because there is so much of iron, it is a pure iron. So he was trying very hard, but he was not succeeded, because I think it just evaporated out. It has so much of energy. None of us should live to be hit by a meteorite, because it is a tremendous event. Okay, if you look at the moon, you will see all those circles, they are all impacts. But in moon, they are leaving the imprint because there is an atmosphere, so it does not burn. But in case of Earth, we have atmosphere, so most of the time it burns, so we don't get it. But otherwise, small pieces comes every day. Hundreds of pieces come every day. So this particular place is called Arizona meteor crater, very, very famous. Fortunately, something happened near Ahmedabad where I used to work. I used to work with Chandramohan Nautiyal at that time, and I was doing my PhD. Okay, so, and in PhD, in our field, you need samples. So every day I was thinking, I need meteorite samples. Okay, so probably I was praying to God that, okay, can I have some samples? Okay, so I joined in 73, 74, 75, I built up the lab. So I was writing to people to get the samples of meteorites, but little bit was coming. But somebody heard my prayer, and there was a meteorite fall 200 kilometers from Ahmedabad. It is called Dajala, a huge meteorite, 60 kilogram. It fell and it fragmented. These people, these students of the local school, they were told that you have to make a brigade and go in a line and collect the meteorites. And why the students? Because their eye is very sharp. See, our eyes are not sharp. Students can see things very clearly. So they were able to pick up all these meteorite pieces and finally collected 60 kilogram of meteorite. And a big piece was given to me and I could analyze them and get my PhD. So my PhD is related to the good wish of somebody. Okay, so basically I am telling that if you have the machine, if you have the desire to learn, if you have the questioning mind, you can do wonders in whatever samples God or nature gives you.
Good morning, sir. You told about the dinosaur spooce fossil. How did we came to know that it was of dinosaur?
These poos or the excreta, there are now a big research team in BSIP, which is in Lucknow, and they specifically have been analyzing these for last 20-30 years. So now there are a class of animals. They have identified that this particular poo belongs to this particular animal, and there are indirect evidences, association of the bed where this animal has been found. And then I am told, I was talking to somebody, that there are the food habits of these animals different. So some of those food particles are inside those poo and petrified poo. That's how it is. It is an extensive research to do this. It is a subject in itself. How to find to belong to whom it belongs, and the size and condition of the environment. Like Mlotiel, yeah.
Sir, on the previous slide, it was mentioned that from studying the radioisotopes of the meteorites, you could determine the location where it was from. What kind of tests determine the location of the meteorite? Like the origin of the meteorite?
Oh, origin of, yeah. So you see, when we say origin, there is a question about the age of the meteorite, because that is intimately related to the solar system formation. So supposing you date the meteorite by some radioisotopic technique, which is now well established, then and you find the age of the meteorite to be very close to, say, origin of the solar system, something like 4.6 billion year, then you know that this has formed at the beginning of the solar system and it has survived. But there are some meteorites which are altered, or even some meteorites which have come from Mars and they were in the surface of the Mars. So the age is a very important indicator. Plus there are now classification of the meteorites in terms of chemistry. They are chemical. So there are 4 different kinds of meteorites. So this subject has been studied in detail, and now the latest attempt is to go to the asteroid belt and pick up a small piece of asteroid, maybe 10 kg asteroid, and bring it to the Earth, so that we can identify chemically whether that particular asteroidal belt or that particular zone is responsible for giving this. But basically meteorites are not from outside the solar system, they are from inside the solar system. But inside the solar system, different distances from the sun have different kind of concentration of elements, and by this elementary elements calculation and the age, we can tell the origin of the meteorite place.
So the lake in Maharashtra of which you showed a picture, sir, it's very obvious that the meteoroid must have had a great speed, velocity. Sir, what would be the estimated diameter of a meteoroid to create a lake of say 3-4 kilometers diameter?
You're very smart. Very good question. See, now the physicists have proposed certain equations, certain advancement in hydrodynamic theory, etc., where if you determine the diameter and if you determine the depth of the crater, because there are various kinds of craters. So if you determine the depth and the diameter of the crater, then you can infer the mass of the meteorite, and usually the velocity is not very big difference because it's the escape velocity close to the escape velocity of the Earth. So it will be some, I think, how much, not all 18? Something like that per second. So it is. Yeah. So that velocity does not change, the mass changes, and this particular one would be, I would say, something like about few tons. Otherwise, you can't make such big one. Arizona was still bigger. Arizona is probably diameter is something like 10 kilometer or so. So depth diameter ratio is a very important thing. But I am very happy that you asked this question. This is a very, very important question. And also angle, yes.
Good afternoon, sir. So first of all, I really admire your work. Secondly, sir, I'm quite curious to know what made you start your research work on meteoroids. And sir, what made you so intrigued about it?
Well, partly is the job requirement, because when I did my physics MSc from Calcutta University, my person who was my friend, philosopher guide, he said you have to do research. Okay, so I have to do research. But research, I have to get some money also because I have to maintain. And then there was a TIFR in Bombay. I don't know how many of you have gone to Bombay and how many of you have seen TIFR. It is a very magnificent place. So there was some advertisement, so I applied, and then they had 2 interviews. Firstly, of course, the career, and it just happened that I stood first in many of the exams before. So they were impressed that, okay, this guy knows a little bit. And then there were 2 interviews, and there were many students, and their first interview I passed. At that time I was fresh from Calcutta, my English was very bad, so I could not understand, I could not speak. So that disadvantage was there, but despite that first interview I passed. Second interview, there was a huge table, there were 20 people and I am in the center. So I am, bakra bolta hai na, you are going to be chopped. So there were so many questions, and there was one person who liked me. And then after the interview is over, that he said that probably we'll select you. Would you like to join our group? So I said, yes, sure. At that time you are relieved that you have got the chance. Okay, so you join any group. So I joined that group. It is called Geocosmophysics Group in TIFR. And what do? They do research on meteorites and lunar rocks. So it was a very impressive thing, that lunar rocks. And I must tell you that I have gone to NASA, I have collected lunar rocks, and I have my PhD part, 50% is on lunar rocks. Lunar rocks mean stones from the moon. So you see in the moon there are some black places and there are some white places. Those white places are called anorthosite. They are aluminium rich. And I got a aluminium rich anorthosite, which was my PhD work part of the thing. It looks like marble. You know, people must have seen marble, white marble. It is like that. So now when you start doing research, then you slowly, if you are curious, I think you can find curiosity in any field, provided it pays. So fortunately, it was paying me salary and my my scholarship, and I was not very, not very money oriented, so I did not go to MBA or other things. So it is love of the subject plus opportunity.
Meteorite which we found, did they have any foreign substance apart from the 118 elements of the periodic table?
Foreign substance is very, very rare, extremely rare. There is a class of meteorites called carbonaceous chondrite, which is high in carbon, and they have detected some amino acids, but then it turns out that many of them were contamination from the earth, because unaware of our, unaware of us, there are, in this room there may be hundreds of amino acids floating around. So any of us are carrying signatures of organic matter all the time. And I was reading a book which says 10% human. Our number of cells in our body, 10% is only us, and remaining 90% is all amoeba and bacteria and parasite and all these things. So those amino acids in that carbonaceous chondrite later on turned out to be of terrestrial origin. So extraterrestrial organic, it is a very interesting subject, I must agree with you. And there is a lot of money is being searched that whether there is any extraterrestrial, are we unique in the universe, or there are some brother, sister somewhere. Yeah, but as of now it does not.
And sir, one more question. You said that children were used to pick those meteoroid pieces. Were they not harmful for them? Like,
No, they have radioactivity. They have radioactivity, but the radioactivity has to be detected only by very sophisticated machine. If you just touch it, it is that much radioactivity is not bad for you. It is very, very minuscule amount of radioactivity. But we can detect it because we have sophisticated machines. That is why. Otherwise, you can't detect that. It is not harmful in that sense. Yes, no.
Sir, in the excreta part that you asked, sir, I wanted to ask that the guts of animals are likely believed to have many different types of microbes. So in passing the excreta, sir, I believe that the microbes inside the semi-solid excreta are would have been supposed to like break it from the inside, even though it have been solidified from the outside. So sir, how was it able to survive the extreme conditions?
Yes. Very, very nice. Excellent question. And this is precisely the research which BSIP scientist is doing. The inside gut bacteria of the animals, when they are present, all animals don't have gut bacteria. Humans have gut bacteria, but many of them don't have. But we have many other stuff, and excreta will have some pollen grains and some kind of amoeba or some kind of parasite, and they find the signature of that by very sophisticated microscope, not ordinary microscope, but called scanning electron microscope. So you make a thin section of that, and all these particles are visible, and there are spores, and there are even there are animals which are spikes. Those spikes are visible. So then you as somebody was saying that how do you know that they are dinosaurs? Then you find out the environment in which these are living. For example, if you have the spores of the water, then you know it is a water animal, that inside from the water it is come. So the petrification must be quickly done in order not to decay. So usually when you have seen dog and various animals, they when they poo, then they cover it up, and usually the mud or other things can be covered up. Even if it is within a month or within few years, then they are safe. They will not decay, and therefore they will remain inside the excreta. And if they petrify, then along with the rest of the things, they will become solidified. And then you can do a thin section analysis and see them yourself.
Sir, even though they are separated from the oxygen, the anaerobic bacteria can still break down it from the inside.
Yes. Some of them can break down, but the bacteria also need oxygen to survive. So if the oxygen is cut off, the bacteria also will die after some time. You see, so in certain situations, anaerobic bacteria is very little. So aerobic bacteria is most of the abundance. So if you cut down the oxygen by covering them by mud or sediments, then the bacteria also will live. So there is a probability of survival. I mean, all of them don't survive, of course. That is correct, because we don't find it everywhere. Now we find it only in some places. So probability of survival, when it is good, conducive to the survival, then you get these samples.
On behalf of all present, I extend my sincerest gratitude to you for taking the time to address our students. Your insights and expertise have greatly enlightened us, igniting our passion for science and inspiring our academic pursuits. Your contribution to our education is invaluable and deeply appreciated. Moreover, delving into the intriguing topic of petrified wood has opened our eyes to the wonders of Earth's history and evolution, inspiring a sense of wonder and appreciation for the natural world. We are also very grateful that you went to the extent of showing us your samples for our understanding. We are truly awed by your expertise and have learned a lot in this short duration. I think I speak for everyone when I say that this has been a one-of-a-kind experience. Thank you.